Completed the whole process of factoring polynomials. As a review, we began with factoring the greatest common factor out of a polynomial before we did anything. At that point, then, if we were able to factor again, we counted the number of terms. We first looked at the situation where there were 4 terms in the polynomial, and we chose to factor that polynomial by grouping. Next, we look at the situation where we had 3 terms in the polynomial. In other words, ax squared plus bx plus c, but there were 2 situations there. One was where a was equal to 1. The coefficient in front of the x squared term was 1. That one was pretty easy. We just looked for 2 numbers whose product is this and sum is the b value to put at the end of each of those binomials. The other situation was a trinomial where the coefficient in front of the x squared term was not a 1, and we tried both trial and error and the alternative method, which the second of the 2, the alternative method, gave you the exact answer first time around. We're now going to look at a situation where you have to factor a polynomial where there are 2 terms. If you're in beginning algebra, you're going to look at what's called the difference of squares. And that will be the only type of problem that you'll solve with 2 terms. If you're in intermediate algebra, there will also be the sum and difference of cubes, and we'll address that as well. Taking you back to previous chapters, let's just look at foiling some special binomials. They're called the sum and difference of like terms. I have 2 examples on the board. The first one, a binomial x minus 2. The second binomial x plus 2. Please notice that the first terms are alike, and so are the second terms, but one is separated by a minus sign, and one is separated by a plus sign. It's called the sum and difference of like terms. When we FOIL these 2 binomials, the first term is x squared. The outer is a 2x, and the inner in this special case is a minus 2x. And as you may recall from the previous chapter, those terms will combine to be 0. The last term, a minus 2 times a positive 2, is a minus 4. And what we're left with here, when we combine these like terms to be 0, is just a polynomial in 2 terms. We call it the difference of squares, and we'll explain that a little bit, but it just means that if I took the variable x and squared it, I got x squared. If I take the number 2 and square it, I get 4. This is what we're going to look at factoring next. Likewise, look at these 2 binomials. They're almost exactly alike. One's got a minus sign, one's got a plus sign. When I FOIL this, my first terms give me 4x squared, then a positive 10x, and a minus 10x. Those will add to be 0. And finally, a minus 5 times a positive 25 is positive 5 is a minus 25. I'm left with here a first term called the perfect square, 4x squared. The middle terms add to be nothing, and then a minus, in this case, 25. Again, these are called the difference, because of the minus sign in between, of squares, perfect squares. And we're going to factor these binomials, polynomials in 2 terms that I've mentioned, into the product of 2 binomials like these. If I were to ask you to factor the binomial or a polynomial in 2 terms, x squared minus 36, you must recognize that this is factorable into the product of 2 binomials, and that is because it's the difference of squares. There must be a minus sign between these 2 terms, and you should expect that you can factor it into the product of 2 binomials, where the first term must be an x in each, because that product will give us x squared, and the next term in each of these binomials will be exactly alike. It will be the square root of 36, which is 6, because I want those 2 numbers to multiply to be 36. I'll put a plus sign in one of these, a minus sign in the other. It doesn't matter which order you write this in. You can write it as x minus 6 times x plus 6, and you have the same thing. It's the commutative property of multiplication. So when you see a problem like similar to this, x squared minus 9, you just need to think to open 2 sets of parentheses, an x in the front of each. The square root of 9 is 3. Put those in each of those spots, put a plus sign in one, a minus sign in the other. Don't care which direction you do that, and you've factored what's called the difference of squares. Another example. If you had 9x squared minus 25, similar to these 2, except for now I put a coefficient in front of the x squared term, you just need to ask yourself, what's the square root of 9? And that's 3. So I need a 3x in the front of each of these binomials. The square root of 25 is 5, so I need a 5 in the back of each. A plus sign in one, a minus sign in the other. That will guarantee, if I were going to check this, 3x times 3x is 9x squared. Again, I'm just going to think about the full check. Here's a minus 15x and a plus 15x. Those are going to add to be 0. And a positive 5 times a minus 5 is that minus 25. Factoring the difference of squares is a fairly easy problem. It's one that we all do quite well with. Problems involving differences of squares. Just wanting to throw a couple of variables in here. I have w squared minus 49z squared. So in the front of each of these sets of parentheses, I need a w because I want their product to be w squared. The square root of 49 is 7. Not only will I need just a 7, I will need a 7z in the back of each of these terms because 7z times 7z is 49z squared, a plus in one and a minus in the other. I'm done. And this one, don't be thrown if the variable is second. The square root of 81 is 9. I'll put that in the front of each. I need a y term in the back of each because their product is y squared. A plus sign in the one, a minus sign in the other, and I'm all set. Again, remember either of these could be written backwards. You could have written this one as 9 minus y times 9 plus y as well. Likewise for this one. As has been in the past, this polynomial has two terms with the minus sign in between, but it doesn't appear to be the difference of squares. So what you have to be on guard for is a problem that's asking you to take out the greatest common factor first. The greatest common factor of each of these two terms is a 6. I need to factor that out first. And in doing that, I'll have 6 times 4x squared minus 9. And then I have to step back and recognize if that is, given that it's two terms, the difference of squares. It will be if I have a minus sign here and if I can take the square root of this and the square root of that. I can, so I'll break this into the product of two binomials. A 2x will need to go in the front of each because their product is 4x squared. A 9 will have to go in the back of each because their product is, a 3 will have to go in the back of each. Their product is 9. One having a plus sign, one having a minus sign. Don't forget to bring down your 6. There's the factored form. Again, factoring a problem that may be the difference of squares because there's a minus sign, but doesn't appear to be at first. I have to recognize that there's a greatest common factor of 6 that comes out of each of these terms. In doing that, I need to put a 4x squared in the front of the binomial because 6 times 4x squared is 24x, and a minus 9 in the back. Now I do recognize something that is the difference of squares because I can take the square root of 4 and get 2, and I can take the square root of 9 and get 3. In doing that, I need to write this as the product of two binomials where a 2x goes in the front of each, and a 3 goes in the back of each, a plus sign in one, a minus sign in the other, and don't forget to bring down the 6. A word of warning. Let's say you were factoring a problem that you thought was the difference of squares, and it appeared or looked like this. 4x squared plus 25. We've said that the difference of squares is a problem where there's a minus sign in between. This problem that I've just put up on the board is not factorable. You have to leave it alone or tell me that it's not factorable. Here's why. Check it out. Let's say that you tried to factor this into two binomials where the beginning, each term in the first position was a 2x because their product is 4x squared. And maybe you then thought, well, I best put a 5 in the back because their product has to be the 25. In doing that, you have to decide about some signs, so we'll throw some plus signs in here. When I FOIL this, I do get that 4x squared, but here I get a 10x, and here I get another 10x, and those will add to be, those like terms will add to be 20x. I do get the 25 I had hoped for, but I don't get the exact polynomial that I started with when I presumably write that in factored form. I get a term that didn't exist in this first term, in this first polynomial. This expression, because there is a plus sign in the middle, is not factorable. We sometimes say that it's prime. Please be careful of that. There are plenty of times when you factor a polynomial in two terms that has a minus sign in between the two terms, where we try to catch you and you don't complete the problem. As long as the exponent of the variable term is even, this is a problem that's factorable. What you have to be careful of is that in the front of each of these two binomials, you need a y squared because their product, when you add their exponents, is 4. The square root of 1 is 1, so I need to put that in the back of each of these, a plus sign in one, a minus sign in the other. Some would say I'm done. But when you look at these two binomials that are left, if you look at the second one, it's got a minus sign in between. I have an even exponent here, and I can still take the square root of 1 again. This binomial can be factored again because it's called the difference of squares. And I'll factor that into, again, put the y's in the front of each, a 1 in the back of each, plus and minus, because if I FOIL that back out, I'd lose those middle terms and I'd have y squared minus 1. Bring down this y squared plus 1. It can't be factored because of the plus sign, and now I'm done. I've factored this problem. So you must go on and on and on until you've completely factored the problem. Don't be thrown by fractions. This is still a simple difference of squares problem. It's got a minus sign in between. Just think about taking the square root of this numerator and denominator individually. The square root of 1 is 1, and the square root of 4 is 2. So I just need 1/2 in the front of each of these binomials, because 1/2 times 1/2 is 1/4. The square root of 9 is 3. I not only need just a 3, I need a 3q. In the back of each of these, a plus sign in one, a minus sign in the other. Introductory algebra students, this finishes our topic or study of factoring polynomials. If you would remember again that your first step, and there is a flowchart in your site, your website that you should print, if you would remember that you should take the greatest common factor out first with any problem. After that, you need to continue the process and you need to count the number of terms. We first talked about the situation where there were 4 terms in a polynomial, and you'd factor it by grouping the first 2 terms, the second batch of 2 terms, take the greatest common factors out and complete that problem. Then we went to a situation with 3 terms, trinomials. Simple situation, a 1 in front of the x squared term. A little bit more difficult situation when there's not a 1 in front of the x squared term. In that situation, you guess and check, or you use the alternative method. And then finally, a polynomial with 2 terms where there is a minus sign in between is called the difference of squares. Next, you're going to look at solving equations by factoring. Intermediate algebra students, we're going to continue with a little bit further discussion of this situation with 2 terms.